Good morning, student. Today we continue our class with the practical demonstration of determination of iodine value and acetyl value. So, as per already we are discussed in theory what is the iodine value and what is the characteristic of iodine value. Why? What is the principle behind the iodine value? Iodine value is basically to determine the unsaturation of oil or fats, the number of bond present in their oil sample or free fatty acids. They absorb the iodine value at their double bond. So let's continue our class with there is some video. So which are described in brief about the principle, definition and procedure. सभ्यता आवाज आ रही है क्या?
Yes, sir.
Iodine number and
Yes, sir.
acetyl number. So let's first look at the iodine number. What is its definition? The definition of iodine number says that it is defined as the number of grams of iodine adsorbed
सभ्यता आवाज क्लियर है?
Yes, sir. Clear.
by 100 gram of fat. Now let's understand that what is this definition. Suppose I am taking one unsaturated fatty acid. So suppose this is one unsaturated fatty acid and here three double bonds are shown, one double bond over here, second double bond over here and third double bond over here. Now if you treat this unsaturated fatty acid with the iodine, this is iodine. So what will happen? Iodine gets adsorbed on this double bond. Okay. So iodine is attracted towards this double bond and it remains stick to that position. So this is a adsorption of iodine. So this is the property of iodine. So this iodine gets adsorbed on this double bond. So this particular property of adsorption of iodine is utilized for the estimation of this iodine number. So it is the number of grams of iodine adsorbed by 100 gram of fat. Suppose you take 100 gram of fat. So this fat might contain unsaturated fatty acid plus saturated fatty acid plus some more molecules. But if you go on adding iodine, what will happen? Whatever fatty acid double bonds are there, that part will be adsorbed by this iodine. So at one point of time, there will be all these double bonds are adsorbed by this iodine, right? So all fatty acid, all unsaturated fatty acids are now iodine adsorbed. Okay, iodine adsorbed. So that quantity of iodine that should be added to fulfill this criteria. So that quantity of iodine in grams, it is known as iodine number. So now this definition is clear that iodine number is defined as number of grams of iodine adsorbed by 100 gram of fat. Okay, so what does this iodine number tells us? What information we can get from this iodine number? See, this iodine number tells us about the degree of unsaturation, degree of unsaturation in any fat, For example, so we have cod liver oil. This cod liver oil has probably the highest iodine number. Its iodine number is approximately 140 to 180 gram, 145 to 180 gram of iodine. What does it mean? See, if you take 100 gram of cod liver oil, it can adsorb 145 to 180 gram of iodine, which is more than the weight of this cod liver oil. So see, this cod liver oil, by this we can get the information that this cod liver oil has the very high concentration of unsaturated fatty acid. The second good example is the linseed oil. It is the linseed oil. If you take linseed oil and you measure its iodine number, it is approximately 135 to 180 gram of iodine. Again here, see, if you take 100 gram of linseed oil, you have to add 135 to 180 gram of iodine in this linseed oil so that all the double bonds get adsorbed by this iodine. Again, here also the weight of iodine is more than the linseed oil. So we can comment on this that linseed oil has indeed very high concentration of unsaturated fatty acid. Now on the other hand, we have one example of the coconut oil. So in this coconut oil, if you measure its iodine number, it is simply 7 to 10. It is very less as compared to this. Only 7 to 10 gram of iodine is required to adsorb or to bind to bind with the double bond whatever unsaturated fatty acids are there in this coconut oil. So by this information we can get an idea that yes, coconut oil, it is full of saturated fatty acid, whereas cod liver oil and linseed oil, they are very high in unsaturated fatty acid. So now let's look at our second quantity, that is acetyl number. So see, this is acetyl number. Now let's first look at the definition of acetyl number. The acetyl number is the number of milligrams of potassium hydroxide required to neutralize the acetic acid. Okay, it is the number of milligrams of KOH required to neutralize the acetic acid produced when 1 gram of fat is acetylated with acetic anhydride. Now this is something difficult to understand. So let's break it down and try to understand what this definition tries to tell us. Suppose you have this fatty acid. Suppose you have one fatty acid, and we know that on one end there is methyl group, whereas on another end there is carboxylic acid group, that is COOH group is there. Now some fatty acid, certain fatty acid contain hydroxyl group also, OH group also as a side chain part. Okay, there are certain fatty acid which is as a side chain OH group is there. So now when you treat this fatty acid with the acetic anhydride, acetic anhydride. Now such hydroxyl group containing fatty acid, when it is mixed up or when it is chemically treated with acetic anhydride, what happens? This OH group gets acetylated. So this thing will happen. Again, this is fatty acid. Okay, this is fatty acid. I'm not showing this methyl end and this COOH end. Okay, so this now oxygen, this hydrogen is replaced by acetyl group, This acetic anhydride itself contains 2 acetyl group. So one of the acetyl group gets bind with this oxygen. Okay, so now what we got? We have acetyl or acetylated fatty acid. This acetylated fatty acid later on hydrolyzed, or you can say broken down. So what will happen? This fatty acid with its OH group is remain free, and free acetic acid is liberated. Okay, so now this acetic acid, it is acidic in nature, and to know the amount or to know the quantity of this acetic acid, we can neutralize it. So, and we will neutralize it with the potassium hydroxide. So what will happen? This is acidic, this potassium hydroxide is alkaline, it is alkaline. So what will happen? Ultimately this acetic acid will neutralized, it will be neutralized. So the amount of potassium hydroxide, the amount of this potassium hydroxide, amount in what term? Amount in the milligram, or acetylated fatty acid. This acetylated fatty acid later on hydrolyzed, or you can say broken down. So what will happen? This fatty acid with its OH group is remain free, and free acetic acid is liberated. Okay, so now this acetic acid, it is acidic in nature, and to know the amount or to know the quantity of this acetic acid, we can neutralize it. So, and we will neutralize it with the potassium hydroxide. So what will happen? This is acidic, this potassium hydroxide is alkaline, it is alkaline. So what will happen? Ultimately this acetic acid will neutralized, it will be neutralized. So the amount of potassium hydroxide, the amount of this potassium hydroxide, amount in what term? Amount in the milligrams, it's a milligrams. So milligrams of potassium hydroxide required to neutralize acetic acid. Now this acetic acid is derived from where? It is derived from acetylated fatty acid, acetylated fatty acid. And from where does this acetylated fatty acid came? Acetylated fatty acid came from the hydroxyl group containing fatty acid, So now let's try to understand this definition. It is the number of milligrams of KOH, right? This is the number of milligrams of KOH required to neutralize acetic acid, this acetic acid. It is produced when 1 gram of fat is acetylated with acetic anhydride. So starting point is you have to take 1 gram of fat, Okay, so this number of milligrams of potassium hydroxide required to neutralize this acetic acid, produced when 1 gram of fat is acetylated, 1 gram of fat which is acetylated with acetic anhydride. So I think now the definition of this acetyl number is clear. Now what is the importance? Of this acetyl number? This acetyl number this acetyl number, it is the measure of the number of OH group present in any fatty acid. It is the measure of OH group containing fatty acid, OH group containing fatty acid, right? Why? Because see, if this OH group is not there in any fatty acid, then there is a no chance of forming this acetylated fatty acid, right? And then there are no chance of this acetic acid, so no KOH is required, right? So this is the measure of OH group containing fatty acid. If some fatty acid's acetyl number is higher, that means this OH group containing fatty acid quantity is higher in particular oil. So let's look at certain examples. So as an example, for example, we have castor oil. Its acetyl number is 150. What does it mean? It means 150 milligram of potassium hydroxide is required to acetic acid, which is produced by the hydroxyl group containing fatty acid, right? So by this we can compare it with some another fatty acid. Suppose we have cottonseed oil. Its acetyl number is 21 to 25. That means, see, now you can compare this castor oil with the cottonseed oil. Cottonseed oil, as its acetyl number is lower than this castor oil's acetyl number, that means cottonseed oil contains less quantity of hydroxylated fatty acid, right? Then we have example of olive oil. This has only 10 to 11. Its acetyl number is 10 to 11. Then we have example of cod liver oil. And cod liver oil, in this case, acetyl number is very less. It is approximately 0 to 1. Okay, so cod liver oil, we can say for all practical purpose that almost nil quantity of OH group containing fatty acids are there in the cod liver oil.
Okay guys, सबको समझ में आया क्या? आप अपना वीडियो अनलॉक कर लीजिए. किसी को कोई डाउट है किसी तरीके का तो पूछ ले अभी, फिर हम आगे इसका प्रैक्टिकल वीडियो देखेंगे कि किस तरीके से परफॉर्म करते हैं. थ्योरेटिकल समझ में आया आपको?
Yes, sir.
आप लोग अपने रेज योर हैंड, यदि कोई क्वेश्चन पूछा जाता है तो मैं उसको अनम्यूट कर दूंगा. चलो ठीक है. विद कंटिन्यू, आयोडीन वैल्यू को कैसे डिटरमाइन करेंगे, प्रैक्टिकली कैसे परफॉर्म करते हैं ये देखते हैं. तो बेटा स्क्रीन ऑन है?
Yes, sir.
प्लीज आप सब लोग ना नोट डाउन करते रहना प्रैक्टिकल का, फिर मैं आपसे पूछूंगा कि कितना अमाउंट किसमें लिया और कैसे किया प्रैक्टिकल.
The iodine value is a measure of the degree of unsaturation in fats and oils. The iodine number or value is defined as the number of grams of iodine consumed by 100 grams of fat. The principle behind the reaction is the addition of halogens like iodine to the double bonds present in the unsaturated fat. The iodine monochloride reagent is allowed to react with fat in the dark. The amount of iodine consumed is then determined by titrating the iodine released on adding potassium iodide with standardized sodium thiosulfate solution and comparing it against the contents in the iodination flask labeled blank. Materials required: iodine monochloride reagent, potassium iodide, 0.1 normal sodium thiosulfate, starch indicator solution, iodination flask, chloroform, fat sample in chloroform, burette and burette stand, glass pipette, measuring cylinder, and distilled water. Procedure: arrange all the required materials on the table. Pipette out 10 ml fat sample from a 2% fat solution prepared in chloroform into an iodination flask labeled test. Stopper the flask. Pipette out 20 ml iodine monochloride reagent into the flask labeled test. Stopper the iodination flask. Swirl the flask to mix the contents. This flask is then kept in the dark for incubation at room temperature for 30 minutes. Meanwhile, prepare the blank sample by pipetting out 10 ml chloroform in an iodination flask labeled blank. Pipette out 20 ml iodine monochloride reagent to the flask labeled blank. Stopper the iodination flask. Swirl the flask to mix the contents. The flask labeled blank is then kept in dark for incubation at room temperature for 30 minutes. Take out the flask labeled test after 30 minutes incubation. Pipette out 10 ml potassium iodate solution into the flask labeled test. Stopper the flask and gently swirl it to mix the contents well. On mixing, the color of the solution in the iodination flask changes to dark red brown. Rinse the stopper of the flask with 30 ml distilled water and mix the contents again. The contents of the flask labeled test is then titrated against 0.1 Norman sodium thiosulfate. Continue the titration till the solution turns pale straw color. Now close the stopcock of the burette. Add 1 ml of starch solution into the flask. The color of the solution in the flask changes to purple-blue. Titration is continued until the color of the solution in the flask turns colorless. The disappearance of the blue color is recorded as the end point of titration. The procedure is repeated for the flask labeled blank. Pipette out 10 ml potassium iodide solution into the blank after 30 minutes incubation. Stopper the flask and swirl it to mix the contents well. On mixing, the color of the solution in the iodination flask changes to dark red-brown. Rinse the stopper of the flask with 30 ml distilled water and mix the contents again. The contents of the flask labeled blank are then titrated against 0.1 Norman sodium thiosulfate. Continue the titration till the solution turns to pale straw color. Now close the stopcock of the burette, add 1 ml of starch solution into the flask. The color of the solution in the flask changes to purple-blue. Titration is continued until the color of the solution in the flask turns colorless. The disappearance of the blue color is recorded as the end point of the titration. The volume of the sodium thiosulfate used is obtained from the titer value, that is blank minus test. The iodine value can be calculated using the formula where equivalent weight of iodine is 127 and normality of sodium thiosulfate is 0.1. Precautions. Iodine monochloride is caustic, so handle the reagent with the gloves. For better results, perform the experiments without any time gap during the titration, as the liberated iodine is susceptible to oxidation by light.
Okay, it's all it's all about iodine value and the practical aspect ki how to perform the iodine value for of fat and oil.